Hello there, this is Hans Forschner with Navcon Engineering. I have a short video here on calibrating sources. In this case, I want to calibrate a Siren at 100 feet from the Siren with a level of 121 dBc. And so here's kind of a quick rundown. So the first thing I want to do is I want to define the geometry of the source, the receiver, and then basically adjust the power level or until I get the right answer at 100 feet. You can use that same process with other sources that are on the ground that are maybe a little bit more complex with multiple receivers all around. And you basically define the sources, the adjacent receivers at 3 feet around the enclosure or at 7 meters or whatever distance you have as a reference. And of course, with any changes in the geometry, the power level has to change to adjust because the distance effect, if you're in the near field or far field, is of course very different. So this is a good way of calibrating your input and making sure that you're getting the right answers or that your source definition is correct. So I'm going into the geodatabase here, and I'll start a very new situation here so you can see from scratch what I'm doing. So I call it Calibration Siren, maybe number 2. And I open up this situation. We'll ask empty situation. Okay, we'll add a new geo file. And at this point, all I want to do is let me put in a point source. So this is again equivalent to a Siren that is on a 50-foot pole. So I'll digitize a point. We call it Siren 121 dBc at 100 feet, and I already have a sound power level here defined. So what I'll do is I'll start with the one with no directivity. So this could be a Siren that is basically rotating in all direction, and I'll just put in like 150 decibels as to kind of start off this this model. And I will say this Siren is 50 feet above the ground, so that's 15.3 meters. And I'll set it to 0, 0. That's the coordinates, so I'll put it in the center of our coordinate system. And here we have our point source. So next thing, I define a receiver. So I'll put that right here. So again, we'll set it at 100 feet, so that's 30.48 meters. And this is 15.3 in elevation, and this is my 100 feet receiver. All right, so with that, this is our basic information. What I also want to do is I want to define the ground hard. Typically those measurements are done over a hard ground. So I'll set up the ground definition, open up a box here, and so this is fine, 1,000 by 1,000, and we'll define that as a hard ground. Okay, and last but not least, I will define some elevation, ground elevation, in case we do want to kind of put in a contour map over this entire area. Oh, that's the wrong one. And I'll set it up to, yeah, that's fine. And at 0 elevation. So 0 meters. So I have basically a ground with 4 points here with 0 meter elevation. I can save this. I can calculate a ground model with that. All right, so this is a ground model. And I'll put it in file number 200. So here we have our ground calculation. Here is a quick view of the situation. So we have our Siren, the receiver, and basically a flat ground all around. All right. So now we calculate the receiver right here. We can just click on this calculate button, and we get 112 decibels at 100 meters. Maybe one thing, if you haven't done that before, you may need to set up a calculation settings. So here you just go through these settings for the single point calculation. So here, make sure that you have DPC set up, the right distance, the right standards. I just do an ISO standard for this like close range calculation, and that's about it. So here we have now 112.8. So this should be 21 dB. So what we can do is we can go back to this input and increase it by 9 decibels, and we'll save it and then rerun this calculation, and now we are getting 121.27. So you can do a fine adjustments by another 0.3 decibels, reduce it by 0.3 decibels, and you get 121 dBc. So this could be done for any type of other calculation. Again, if you have a source with receivers all around, like an enclosure with 85 decibels, so you can set up your source, put your receivers around it, and do the same calibration to make sure that your prediction is giving you the same answers. So this concludes the calibration part of the Siren calculation. Thank you for listening or watching.